Namaste and welcome to these sessions. Today we will discuss about the different numerical problem related to forces acting upon a tillage implements. It's under the Farm Power and Machinery courses of Agriculture and Forestry University for BSc program. There are some past questions arise to your final examinations. These are related to uh, forces acting upon the tillage implements. Here the some angles are given and the total pole is given here, and we have to resolve this into the different axes and to find out the draft, side draft, and also power side drawbar powers. Okay, let us take an example of the numerical problem here. The question said the line of pole on an implement is 15 degree above the horizontal and is in a vertical plane, which is at an angle of 10 degree with the direction of travel. Okay, then calculate the draft, side draft for the full of 500 kg. And also we have to find out the drawbar horsepower required at the 4 kilometer per hour operation. Okay, before drawing this numerical problem, we should know about the different term like the line of flow and this angle meaning and then that the direction of travel and draft, side draft, and the drawbar horsepower. After knowing this term, then only we can solve this problem effectively and understanding uh, this problem practically. Let us take an example here. Tillage implement and implement is here. It may be ambiplo here, and there we can consider a point like that is the center of resistance on which the all the forces will be reacted upon it, and the total resultant force will be passed through that point. We can consider that point as the center of resistance, which is the imaginary ideal point here. And this NB flow is traveling along that direction, and that is the direction of travel. Or the it is drawing a tillaging operation on that direction. It is tillaging on that direction. That is the direction of travel of that implement. That may be x-axis. Along that direction, the total forces acting upon the direction of travel, that is L here, that is the draft. It is called the draft. And on its perpendicular side, is 90 degree with its, but in the horizontal plane, on forces acting upon the implement, that is the S, that is the side draft. It's called the side draft, and the role of the draft is to drag the implement and perform the tillaging operation. But the role of side draft is to hold hold that implement on the direction of travel, or it maintain the direction of furrow or the line of furrow. It maintain the line of furrow like some force acting upon that implement here. At that condition, the implement cannot escape from that side. Or it maintain a proper line of furrow. Okay, that is the side draft. It exerts the side exerts and it also maintains the side suction also. And there will be another component, that is the V, that is the vertical component. It maintains the total weight and that the reaction provided by the soil on that implement. Okay, we have to resolve that the total resultant force, or that is the total pull applied on that tillaging implement, that is the F, the total force, and this is the center of resistance, and this point is called the center of pull, and this line is called the line of pull. Okay, this is the direction of travel, and I think we know about the different term except this angle. Let us visualize this problem in the 3D way. Let this vector, this red vector will be the P, that is the total force acting upon that implement. That is we applied P amount of pull on that implement. That is here question in the question it's given as the 500 kg here, and we have to resolve that p into the different axes. Let us take an axis that is x-axis. X-axis is the axis along on the direction of travel. On the horizontal plane, making in the 90-degree with the x, and that is the another axis is there, that is the y. Here in practical it will be angle 90-degree, but in we are plotting that 3D diagram in the 2D plane, so here the angle is not seen at the 90-degree here. And another axis is the z-axis, that is along the vertical direction. Okay, we have to resolve that p into in these three axes. Let us make in plane that passing through the p and the z-axis that contain two lines, that is the z-axis and that p vector containing plane, that is a coplanar plane that contains total applied force, that is the resultant force, that is the p, and the z-axis. This blue color plane is a plane that contains the total resultant force and the z-axis. And another plane that is brown color here, and that is the xy plane. It's a horizontal plane. Okay, it's a horizontal plane. On the question, it has been given that 15 degree above the horizontal. What does it mean? It means that the line of pull, is uh, pi angle above the horizontal plane. Okay, the P makes an angle of pi with the horizontal. That is pi. We can consider it as the pi. On the question here, it has given the 15 degree. And it also said that it is in vertical plane. What does it mean? It means if you illuminate that P from that side, or if you give some light from this side, then if you see some kind of shadow on the xz plane, then there will be an image form. That is a shadow of P on the xz plane. It makes an angle of pi. That is said on the numerical problem here. Okay. Now another angle is also given, that is the 10 degree with the direction of travel. What does it mean? It means this is the x-axis is the direction of travel, and that P makes an um, angle of theta, that is the 10 degree with the direction of travel. It means that is the theta angle. It makes the theta angle with the x-axis. Okay. This is the exit plane. If you transform that P into, or if you make a shadow, or if you project that P on the exit plane, then you can see that kind of projection here, and that is the image of P on the exit plane. And then this angle will be pi. Okay, this angle will be pi. And now if you project that P on the horizontal plane, if you make a shadow of uh, that force on the horizontal plane, then you can see and that type of image on the xy plane. That is the position of P on the xy plane. It is on the horizontal plane. First of all, we can find out the value of that position on the xy plane. Yeah, we can assume it the d, and it is d equal to p cos phi. How is it p cos phi here? It is the resolution of the resultant force p on the xy plane. That is the p cos phi. Okay, if this is an vector like the f is a force, and that's we have to resolve into two axes, like the in x-axis and in y-axis, and f is making an angle of alpha with the x-axis. At that condition, the amount of f along the x-axis is uh, fx, and along the y-axis is fy. Okay, in that condition we had to find out the fx and fy here, and like we can complete a triangle, like we can transfer the fy, like parallel transfer the fy from there to there, and making a complete triangle here. Okay, this is the fy. In that condition we can apply the simple trigonometric relation here. If we take the sine alpha, at that condition that is the perpendicular Fy divided by hypotenuse, that is F, or Fy equal to F sine alpha. Similarly, in the x-axis, if you take the cosine alpha equal to fx divided by f, or fx is equal to f cos alpha. By this way, we can resolve the and force into the orthogonal to axes. By this way, we can resolve that the p into that d direction, that is the p cos phi. Okay. Similarly, we can resolve that d into the x-axis and y-axis. It's like we already did on the right side diagram. Here, along the x-axis, there may be a component of d, that is a small green vector here, and that is the L equal to d cos theta. That is the d is the resultant force on the horizontal plane, and if you multiply with the angle made between the x-axis, that is the theta, that is L equal to d cos theta. That is L is the draft equal to d cos theta. If you put the value of d equal to p cos phi to the uh, L cos theta, then you can get the p cos phi multiplied with cos theta. That is the relation for the draft force. Similarly, along the y-axis, and that is the component of d is d sine theta. If you put the value of d, that is the d cos phi multiplied with sine theta. That is the component of p on y-axis. That is the side draft. We got the relation for the graph, that is the p cos phi and cos theta. We got the relation for the side graph, that is the p cos phi multiplied with sine theta. Sometimes you may be asked to find out the vertical component b. At that condition, you can also easily find out the vertical component. Let's do it. On the exit plane, the component of the p will be, that is the p cos theta, is that angle is theta on the horizontal plane. At that condition, you can resolve that the exit equal to p cos theta to the z-axis and x-axis. That is the it's making an angle of phi with the x-axis. At that condition, uh, along the z-axis, it will be the p cos theta multiplied with sine phi. That is p cos theta multiplied with sine phi. Okay. By this way, we can easily result the total resultant force or the total force applied to an implements to different axes, and we can calculate the different like this horsepower and other things also. Let's do the numerical here. We got a relation for the draft, that is the p cos theta and cos phi. Both terms are in cosine, and theta is the 10 degree. Theta is 10, and phi is here. Phi is equal to 15 degree here. If you put all these values on that relation, then you can get the value of 475.62 kg. The value of P is given here, that is the 500 kg. And sometimes you may be asked to find out the draft in Newton. At that condition, you can convert it into the Newton, that is the SI unit, 9.81. You can multiply it with 9.81. That is the acceleration due to gravity. Okay, that is the acceleration due to gravity. And then next is the side draft. Side draft can be calculated the p sine theta and cos phi. Okay, we already find out the relation that is here, and you can find out the value of the side draft is 83.86 kilogram. And then for calculating the drawbar horsepower, the drawbar horsepower is always calculated with using the draft force, and power, you can find out the power equal to power relation is work divided by time, And then work is calculated by the force multiplied with the distance or the displacement travel using that force along the direction of the force and divided by time is here. If you order these three term into on these two term, then you can get the relation that is the force multiplied velocity or the speed. That is a power can be defined as the multiplication of the force and velocity. Okay, by this way. That is the scalar product of force and velocity. Question has asked the find out the power in horsepower, that is the HP. It has mentioned the unit of power in HP. If you calculate this uh, power in watt or other term, then that will not be the complete solution of that numerical. At that condition, you have to convert it to the HP. First of all, force multiply with the speed, and then it gives the uh, power in watt, and then if you divide watt with the 746, then you can convert it to the SP. Okay, and always take care and the force in here it should be the draft. Draft is given here, that is the we calculated here is that is the 475.62 kg, and if you multiply it with the acceleration due to gravity 9.81, then you can convert it to the Newton, that is Newton, and then speed is given here, that is 4 kilometer per hour, and you have to convert that kilometer per hour to meter per second. For kilometer to converting it to the meter, then you have to multiply it with the 1000, and for converting this hour to second, you have to divide it with the 60 for converting it to minute, and minute to second also divide it with 60, and then divide this whole by the 746, then you can get the value of horsepower, that is the 7.046 HP. Okay, that is the drawbar horsepower. And sometimes you may be asked to find out the value of vertical component, that can be find out using that list. Okay, it is a very simple and easy numerical, but most of the students do their mistakes while considering that the value of uh, theta and pi. That is, most of the students consider that the value of theta instead of pi. Like the if you assume like value of theta is the 15 degree and the value of pi is the 10 degree, then your solution will be wrong. Another mistake being chance is here. That is the uh, you may be asked to find out the value of side graph, then you wrongly calculate the value of vertical component, or you may be asked to find out the vertical component, then you wrongly find out the value of side graph. That will be mistake. And another thing is here the conversion of the unit, and some most of students memorize the formula and they use this value on this formula. At that condition, they do not take care of the unit, and their numerical will be wrong. And the force to calculate the drawbar horsepower, you should always use the graph only, not that 500 kg or that 83.86 kilogram. You should always use the graph force. Okay, here are some numerical problem you can practice yourself, and if you have any confusions regarding this topic or any other, you can mention me on comment, or you can contact me on other social media. And sometimes you may be given only one angle, like here one angle is given, that is the 30 degree, that is it is the pi as our previous discussion. Here the theta is not given. At that condition, you can assume theta is 0 degree along the direction of travel. Okay, and you can practice this well, and sometimes you may be asked to find out the unit graph. You will define this term later. And there are some term you can take a screenshot and read for this term to be familiarized with this term. And there are other term also like center of power, center of precision, pull size. Okay, and then sometimes you may be asked to find out the unit draft. Unit draft can be find out by dividing the total draft with the cross section area of the tillaging, or that's travel. That is the A is the cross section area of the that furrow, and at that condition you can easily find out the unit draft by dividing the draft with cross section area. Okay, thank you for your attention, and if you really like and easily understand that's the numerical program, it will obviously help your final examination and user practical understanding. Uh, if you think it's such helpful, then you can like, subscribe, and share to your friend. Thank you for it.